Good morning, students. Welcome to Good Samaritan School online classes. The last classes, we finished this chapter, periodic classification of element, and that we learned valency, atomic size, metallic and non-metallic properties. But one thing we need to learn even more on this, especially when you look at this periodic table, as we go through properly, we have 18 groups and 7 period that we have learned already. And the second thing is, if you see that first period, we have two elements are there, right? Two elements are in the first period. If you watch carefully, this periodic table, it looks like shells. Okay, the elements arranged in the shell. That means in the first shell, we have only two elements, right? So only two elements in the first period. The second period, we have 1, 2, 3, 4, 5, 6, 7, 8 elements. Third shell also, I want you to remind you, in 9th standard, we have learned that first shell 2, second shell 8. Third shell also, I told you to make it as 8. Remember that? Yes, you can see in the third shell also, we have 1, 2, 3, 4, 5, 6, 7, 8. And in the fourth shell, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it comes as 2, 8, 8, 18 and 18. Here it comes as 32. The 32 kahan pe? Just watch carefully. Here we have 1, 2, 57, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Then 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. Understand that? So the first shell 2, here it's 8, again 8, 18, 18, then it comes 32. This is how the elements are arranged in the shell. Okay, this is how the understanding of how the elements are arranged in the shell. So it goes on like that. In today's class, we are going to learn even more about the topic called what are the S block elements, P block elements, D block elements, and F block elements. I hope you remember this thing what I told you in the last class. That means S block elements are first and second group. P block is elements are start from 13 to 18th group, and the group which is present between 3 to 12 are all D block elements. That means these are transition metals. That means it's present between S and P or transition metals. So there are some metal which is present inside the transition elements. For example, lanthanide and actinides are present inside the transition elements. That is why they are said to be inner transition elements present inside the transition metals. And they are represented at the bottom of the periodic table as lanthanide and actinide groups. And these two are inner transition elements. In other words, they are said to be F block elements. So these are the things only we are going to discuss in our class today. But even we are why I am teaching this, the only reason is, if in your new book, if you watch carefully, this is my old book and it shows like this, and this line which is M shell 2 into 3 square 18, this is not given in your new book, right? Am I right? So to understand this concept more on that, so we are going to learn about electronic configuration. So anyway, if you understand this electronic configuration, that will be easy for you to understand much better. And in your new book, it is written something like you can study in our higher classes, 11th standard. So what I am thinking that if you understand this electronic configuration concept in 10th standard, so it will be easy for you to understand more on 11th standard. Okay, so shall we go into study about the electronic configuration and S, P, B, D and F elements? Yes. Okay, student, this is a rough figure of periodic classification, periodic table. and here only I told you the first and second group elements are said to be S block elements. So I'm writing it as S block. Why we are giving name as S block? And that we will be learning. And the topic from here to here, 13 to, this is P block elements, and this is D block, and this is F block elements. Both these two are F block elements. Okay, to understand this concept, before that we are going to learn on electronic configuration. Electronic configuration, before that we learned as like this. We learned as shells. That means we have K, L, M, N, like that we learned. That means K shell is the first shell, L is the second shell, M is the third, and N is the fourth shell. Am I right? Number of shells we learned. And also we learned one more thing, that K shell, using the formula 2n square, we learned that K shell could occupy 2 electrons, L can occupy 8, and then it comes 18, 32, it goes on like that using this formula, right? But this, we are not going to learn this in our higher classes. Instead of learning shells, as I told you, shells, but we have subshells present inside the shell. ये subshell कहाँ पे होता है? It present inside the shell. What are they? That means K shell की अंदर we have only one subshell, that is S. Where this S shell subshell is present inside K shell, right? And this S subshell can occupy only 2 electrons. ये भी याद रखना है. Okay, S subshell can occupy only 2 electrons. And L shell, okay, L shell के अंदर we have 2 subshells. One is S as well as P. कितना subshell है? S भी है और P भी है. And how many electron this subshell can occupy? L के अंदर, as we have 2 subshell S and P. This S can occupy 2 electron, that we know already, okay, and P can occupy, we have 6 electrons, okay. M के अंदर we have S, P, D, 3 subshells होता है. N के अंदर we have S, P, D and F, so 4 subshells होता है. I repeat once again, shells K, L, M and shells are there, and we are talking about subshells. That means subshells are present inside the shell. Shell की अंदर होता है. And what are they? Yes, I just want to simply write it as S, P, D and F. These are the subshells. And how these subshells are present? In K shell only one subshell is there, that is S. L shell के अंदर S भी है और P भी है. M के अंदर S, P, D तीनों सबशेल है. N के अंदर S, P, D and F भी होता है. As I know that S can occupy only 2 electron, P can occupy 6 electron, D can occupy 10 electrons and F can occupy 14 electrons. ये याद रखना है. Okay, so as we know already, K could occupy 2 electron, L can occupy 8 electron, like that. Here S could occupy 2, P can occupy 6, D can occupy 10, F can occupy 14. Clear? Will you able to understand this? Okay. How we can use this and write an electronic configuration? To write an electronic configuration, there is one simple principle is there to write. What is that principle? The principle name is Hofbauer principle. This is what the principle of Hofbauer principle. What are they? In that we can make a diagram so that it will be easy for you to understand it more. That means 1s in first shell, that means this is the first shell. You think like that. This is an nucleus and this is the first shell and this is going to be the second shell, and it goes on like that in an atom. So this is what the first shell. Think in that way. First shell. And this shell is K shell. K shell के अंदर क्या है? Only S is present. I just simply draw like this so that you understand the shell. You think that this is a nucleus and this is the first shell, and 1s, that means first shell, 1 represents first shell, yes means first shell के अंदर क्या है, only one subshell is present, that is yes. And then उसके बाद क्या आता है, another shell आता है, so that is 2s. second shell के अंदर yes भी है, p भी है. Why I am writing 2? Because that is actually a second shell, and second shell के अंदर yes भी है और p है also there. Will you able to understand this? Yes. So third shell के अंदर क्या क्या है, yes, and then 3p, and then 3d. And then fourth shell के अंदर क्या है, yes, 4s, 4p, 4d, and then 4f. Will you able to understand this? Yes. And then if I go on, 5s के अंदर भी 5p, 5d, 5f ये सब होता है. Okay, let's understand this. How can we make a formula? So I am going to draw an arrow mark like this. Okay, so it start with 1s, then 2s. Always follow the arrow mark which is coming downward. So first is 1s, and then ऊपर जाके और 2s. Okay, and then और ऊपर जाके 2p, then 3s, then ऊपर जाके 3p, then 4s, then उसके बाद 3d, 4p, then 5s, then ऊपर जाके 4d, 5p, then 4f. It goes on like this. Maybe it confuses you, but I can write it so that you can understand it. So first it is start with 1s, okay, then ऊपर जाके नीचे क्या आ रहा है, 2s आना है, 2s, and 2s के बाद क्या आना है, 2p आना है, 2p, then 3s, and then ऐसे ऊपर जाके 3p, then 4s, then 3d, 4p, 5s. So why I'm writing this? What is this actually? This is how electrons are arranged in a shell. This is how they are arranged. It is not simply arranged like K, L, M and shells. पहले K shell में तो for example if I am going to draw a structure of oxygen, oxygen को क्या लिखेंगे, atomic number 8. So electronic configuration क्या लिखेंगे, 2, 6. इसका मतलब क्या है, फर्स्ट शेल में 2 दे दो, K में 2 दे दो, एंड बाकी कितने इलेक्ट्रॉन है वो लास्ट शेल में दे दो. लास्ट शेल में कितने आ रहे हैं, एल शेल में 6 आ जाएगा. Yes, it is right, but the way of writing changes. That is what I am trying to say. How it is changes, you can see that. How can I write the oxygen for here? Oxygen, I am going to write it in this format. Okay, let's see. So yes, कितने इलेक्ट्रॉन लेता है, 2 is the maximum. Am I right? So I can put 2 here. कहाँ पे yes आ रहे, वहीं पे आप 2 डालना है पड़ेगा. ओके, एंड वहाँ पे P आ रहे, P मैक्सिमम कितने इलेक्ट्रॉन लेता है, 6 इलेक्ट्रॉन लेता है, एंड D कितने इलेक्ट्रॉन लेता है, 10 इलेक्ट्रॉन लेता है. Am I right? और F कितने इलेक्ट्रॉन, 14 इलेक्ट्रॉन लेता है. So that we need to arrange according to the element what we have. For example, oxygen atomic number 8. So how can I write it, 1s2. That means first शेल में yes सब शेल है, वहीं पे 2 इलेक्ट्रॉन दे दिया, एंड बाकी कितने इलेक्ट्रॉन है, 2 देने के बाद 6 इलेक्ट्रॉन्स आर देयर. तो दैट विल गो टू द सेकेंड शेल. सेकेंड शेल में क्या क्या सब शेल है, yes भी है और p भी है. So 2s2. Then first yes सब शेल yes only filled, not p directly. पहले फर्स्ट शेल में yes सब शेल फिल हो रहा है, बाद में एक्स्ट्रा इलेक्ट्रॉन गो टू द सेकेंड शेल, इन दैट ऑल्सो पहले yes फिल हो जाता है पहले, एंड देन ओनली रिमेनिंग इलेक्ट्रॉन गो टू p. ओके, सो 1s2, 2s2, देन 2p. कितने इलेक्ट्रॉन मैक्सिमम लेता है, ये 6 इलेक्ट्रॉन लेता है. मेरे हाथ में कितने इलेक्ट्रॉन अभी, 2 + 2 4 हो गया, और बाकी कितने इलेक्ट्रॉन है, Yes, 4. So this is what the electronic configuration of oxygen. Will you able to understand this? Yeah, I'll do some more example. We'll write for sodium. Sodium atomic number 11. Can we follow this? So 1s2, पहले फर्स्ट शेल में 2 इलेक्ट्रॉन दे रहा हूँ, then the remaining electron go to the second shell. 2s2, 2p6. वहीं पे क्या हो जाता है, फर्स्ट शेल में यस सब शेल को दे दिया 2 इलेक्ट्रॉन, सेकेंड शेल में यस को पहले दे देता है और पी कंप्लीटली फिल हो जाता है. सो टोटली कितने हो गया, 2 + 2 + 6 10 हो गया. सो बाकी कितने इलेक्ट्रॉन है इसमें, एक ही इलेक्ट्रॉन है. दैट विल गो टू द नेक्स्ट शेल. कहाँ पे, थर्ड शेल जा रहा है. थर्ड शेल में यस सब शेल फिल हो जाता है. सो हाउ कैन आई राइट इट इन दिस मैनर? यस, यू कैन राइट के शेल 2, के शेल 2, एंड दैट के शेल के अंदर ही ये 2 होता है ना, सब शेल यस होता है, उसके अंदर 2 होता है. एंड एल के अंदर वी हैव यस एंड पी. एम आई राइट? दैट मीन्स वी सिंपली राइट इट एज के एल में 8 इलेक्ट्रॉन, but here we are splitting it and writing. So 2, and then we just write it as S and P. 8 हो गया, and then M में 1 हो जाता है. So 2 8 1 आ गया. Will you able to understand this, student? I do one more example also, for that you can understand more on this. We write for a carbon atomic number 4. How can I write like this? 1s2, 2s2, sorry, atomic number 6 carbon है ना, 1s2, 2s2, 2p2. So this is the first shell. First shell 2, 4. ऐसे लिखते हैं ना हम electronic configuration. But we are splitting and writing. That's what the example. You can ask me a question. So here first shell, second shell, S and P are there. But in third shell we have S, P, D तो आना चाहिए ना, क्यों 4 S आया? It means that D shell is little bigger, harder. So पहले yes shell fill हो जाता. For example, if I'm talking about mm, uh, let's take one more example. Potassium लेते हैं हम. Potassium atomic number 19. Okay, let's see that. 1s2, 2s2, 2p6, 3s2, 3p6, 10, 18 हो गया. And then we can't write 3d1 नहीं लिख सकते. Am I right? Why we should not write 3d1? क्योंकि 2 + 2 + 6 10 हो गया, 10 + 8 18 हो गया. सो एक ही इलेक्ट्रॉन बचा है ना. वाई वी कांट राइट इट एज 3d1 क्यों नहीं लिख सकते? इट इज बिकॉज इफ आई एम पुटिंग वन इलेक्ट्रॉन इन डी सब शेल, मिनिमम हाफ तो फिल होना चाहिए, देन ओनली दिस डी कैन एक्सेप्ट. नहीं है तो दैट विल गो टू द नेक्स्ट शेल. दैट मीन्स 4s1 को जाएंगे. क्यों 4s1 दिया? It means that it needs to be off filled completely. So that is why I am writing it as, this is the electronic configuration of potassium. 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 is the electronic configuration of potassium. Even for calcium also, we have to write like this: 2s2, 2p6, 3s2, 3p6, 4s2. That is why electronic configuration of potassium, we write it as 2 8 8 then 2. मे बी यू कैन, आप 8th में, आप 9th में आप क्वेश्चन पूछ सकते हैं ना, कैल्शियम सर वाई वी आर राइटिंग इट एज, वाई वी कांट राइट लाइक 2 8. यहाँ पे तो वी कैन राइट इट एज अनदर में जा सकते हैं ना, 2 8 18 18 है तो वी कैन राइट इट एज द ऑल दीज एलिमेंट्स एज 2 8 then 10. as in some of them are asked me. So 2 8 10 तो लिख सकते हैं. Why we are writing it as 2 8 8 2? It is because of this. Will you understand this? So we can't write as 2, 8, 10. We have to write it as 2, 8, 8, 2. It's because of this rule. Hope you understand this. Come back to this S block, P block, D block, S, P, D, F, periodic table. Sir, why you are telling this? Why it is arranged in S block? Why it is in P block, D block and F block? There also, there is one trick is here. It means that if you watch it, all these elements in the S block elements, all the elements, they start with S and end with S only. And here all the P block element, they start with S and end with P only. All the D block element, they start with S and end with D. So, and all these F block element, they start with S and end with F. That is the reason we are arrange themselves in S, P, D and F. Let's give one example for that. Okay, let's take one example of lithium. Okay, we'll take a little amount of sodium we have just seen. Just go through that. Sodium. You see that? Sodium, first group element, they start with S, end with S. Will you understand that? And end point also 3S1. That is why the valency also 1. Potassium, start with S, end with S. Will you understand? That is why they are in S block element. And also 4S1. It means they are in the first group. Okay, let's take the second group element. Calcium is in second group element. Start with S, end with S only. But you look at the element electron in the last shell, 2, valency 2. Will you understand that? Okay, let's move on to oxygen now. Okay, oxygen. Oxygen, what is the number of कौन सा group है ये तो P block element है ना. Look at it. Oxygen are in P block element. And what is the number of group here for oxygen? 16th group. Valency 2 होता है. Am I right? Okay, let's see here. Oxygen start with S, end with P. Will you understand here? P. 4 electron. That means as I told you, P में कितने electron होना चाहिए? 6 होना चाहिए. Am I right? तो यहाँ पे कितने हैं? 4. It means कितने electron और चाहिए? -2. Will you understand? 2 electron चाहिए. So that becomes the valency. Will you understand? Yes. We'll see for some more example. Even you can watch all these elements here. They start with S and end with P1. Start with S, end with P2, P3, P4, P5 and P6. P खत्म हो जाएगा. P में कितने इलेक्ट्रॉन होना चाहिए? 6 इलेक्ट्रॉन है ना. So P खत्म हो जाएगा. D also the same. Start with S and end with D. This I want some of you to try it in your home. Any one of these elements. I will give you some elements so it will be easy for you to do in your home. Your homework is do the electronic configuration for vanadium. It is in D block. Okay, vanadium. And then do for, I'll give a simple one only, chromium. Okay, chromium, vanadium, both are in D block elements. ये दोनों का आप electronic configuration लिख के you then submit it tomorrow. And I hope you understand the reason behind S block, P block, D block and F block, and the principle behind that Hofbauer principle, and also how to write these type of electronic configuration. If you understand this concept, then you can easily understand the valencies also very easily. Clear, student? And hope you understand this. And still, if you have any doubt, please do ask me in my WhatsApp number. Thank you and have a nice day.